Hello folks and welcome to my veritable sauna, because it seems that the British summer has caught up with us at last, and that means it's about 32 degrees outside, which of course means about 35, 6, 7, who knows in here, because we've had the machine going on all day and that belches out quite a lot of heat, and whilst there is ventilation from the open doors, my space is very, very small. It doesn't always look it from the camera, but it is absolutely tiny. If I just walk over here, oh look, I'm at the end of it already, so if we just come back here, there's not a lot of space to play with, but we did make some really cool stuff. So we took this massive piece of aluminium and we reduced it to one mighty fine looking rear panel. So this is a really exciting part of the build because it's the first major part of the structure that interfaces with the components. So I'm going to show you exactly how it works in a minute, but for now I'm just going to go over some of the things that we did. So it was largely very similar to the previous parts, which is why I didn't cover it to begin with. Most of the toolpathing is pretty straightforward. We've got some big 2D pockets here, which I did with a 3mm end mill, again 0.5mm step downs, and then just using a sort of 1000mm per minute feed rate. Pretty standard stuff. Now what I did is I've worked my work holding into the plate itself, and these are also parts that will mesh into the parts on the inside, so that means that when it's all finished up, these holes here will all be filled up with screws and look rather nice, hopefully. So again, I'm going to be doing the whole glass blasting thing so it can match up with the base plate, and I think that should look rather good. We're then going to be putting it back onto the machine and then doing all the chamfers, as well as some rather special stuff, which I'm going to go into in a moment. Aside from that, it's a fun machining job, quite lengthy. There was actually a lot to do, especially since this particular piece of plate was 10.6mm thick, so I did have to surface it down to about 10mm to be in line with the 3D model. But aside from that, quite straightforward, no real problems, and actually not that exciting from a sort of experimental point of view. The exciting stuff is what we're going to be doing later. What makes this panel special is the way it interacts with the motherboard. So obviously we have a power supply mount here for an SFX power supply, but we also have this pocket here. Now what is that for? Well, basically here's the Aqua, and if we take a look at the back, we have obviously our I/O section. Now this one comes with a plate on the back here, which is a really nice feature for standard cases. This is not a standard case, come on, we can do a bit better than that. So what we're going to be doing is we're going to be milling this into this. Now I am fully aware that that means I will not be able to upgrade this with a new motherboard, but come on, we're doing a full scratch build with all these custom components. If I need a new one, I'll just make a new one. That's the way I'm going to be doing it. So this means we can do some really exciting stuff. Now I have actually done this a long time ago, before I had my CNC machine, actually before I was even at BitTech. So I'll throw up a couple pictures of that now, but that was all done by hand. So I know I can do it. That was done using needle files, and it was an absolute ball ache, but it looks fantastic. So I'm hoping to replicate that, but with even higher detail and doing it in a way that will not be possible by hand. So what we're going to be doing is we're going to glass blast this, so have a nice sort of even finish along the bottom of this pocket, and then we're going to use some tiny end mills to construct all of these port locations on both the motherboard and also the graphics card. Because what we're going to do is we're going to take this 2080 Ti, we're going to remove the bracket on the back here, it's going to be sitting like so, and it's going to go on the other side of this. So it's going to sit like that, and this will have a nice flush back to it in exactly the same way as the motherboard. I've seen this one done before, but having both done is quite tricky because trying to get all the models to line up properly is a pretty challenging thing to do. But I think we can do it, and it should be really exciting. Now additionally, what I'm also going to be doing is giving sort of bright chamfers around the outside. So of course this will all be matte, so we're going to add some chamfers around these parts here, which will really pick up the light nicely. We're going to add some along the outside here to break up these edges, because at the moment these are very sharp. I haven't deburred them because we're going to be chamfering them later, and that's how that's going to work. I'm going to add another one down here because that's an edge which is going to be just open to the elements. This edge is going to interface with some wood later on, and then this top section is going to go into a distro plate. So it should be quite exciting seeing how all that turns out, and that's where all these screw holes go. So these will interface with that distro plate. So for the time being though, let's get this all glass blasted. Well, I'll do that in the morning at least. We're going to get it all glass blasted, and then I'll explain exactly how we're going to do it with the end mills and why I find them quite so scary to use. Is all nice and bead blasted now, which took a lot longer than I was expecting, mostly thanks to the heat again, because of course I would put my janky cardboard box right next to the window and the sun comes over the house, shines straight in, and then is all over my back, and this is a black t-shirt, so it's basically turning me into some sort of tasty pot roast. But in the meantime I did manage to take a few breaks and get it done, and I think it looks really rather good. But of course we need to put it back onto the machine to do the final cutouts for the I/O placement, as well as the aesthetic chamfers and things, which leads me on to that point that I mentioned a little bit earlier, because I wanted to explain some of the end mills I'm going to be using and just why they always scare me to use them. So let's have a look. Starting off, you see me facing with this big boy. This is a 20mm facing mill. Now this is about as big as I can get on my machine. It has an 8mm shank. I can't go any higher than that because I only use ER11 collets. So that's about as large as I'd be comfortable going. But what we're going to be doing is much smaller. By contrast, that's a 6mm 4-in-1 end mill. You can see how much smaller that is. Now that's what I usually use for roughing. So if I'm going to be doing roughing of plastics, I use these a lot. But if I'm doing roughing of aluminium, that's a little bit too big and I can't get a very good step down with it. So I use these, which are 3mm. So you can see how much smaller those are already. And we're going to go a lot smaller than that. We're going to be using one of these to do the roughing, which is a 1.5mm end mill. So you can already see how that is going to be a fair bit more terrifying to use than that. Although it's quite stubby and has a 6mm shank versus the 3mm here, these will still snap quite easily. That said, much easier than the one we're going to finish with, and these are the ones that truly terrify me, because this is a 1mm. Now compare that, I've just taken out another 1.5mm, and this is a 1mm end mill. Now I do have smaller than this as well that I've used for engraving purposes, but this is about as small as I'm comfortable going for regular style milling. And look how small that is, even compared to a 1.5mm. Look how much of a difference it makes. The other thing is that these have got very long flutes. Now I actually primarily got this one for plastic work, but it of course does work fine in aluminium as well. But I've got to be very, very careful about how I use them, because the biggest issue with using tiny end mills like these on this sort of machine is the lack of rigidity. So when you've got a really beefy machine, like one of the proper Datrons or a really high speed thing like the Kerns and all of that, they are incredibly rigid. And that means that when they change direction, as well as having very high quality servo motors and similar, they don't at all vibrate. So when your tool is moving around a very complex path, it basically just stays true, and none of the vibration from the work holding and all that's transferred into the tool, which means it can cut very efficiently, which allows you to do much more impressive cuts than you can on a machine like mine. The problem with my one is, of course, when you rapidly change direction, especially when it's very small, everything's sort of magnified. It has the effect of basically causing the tool to vibrate. And when it vibrates, it becomes weak. It can take too much or too little, and that variation in the cut can snap end mills very, very easily. So I've tried doing some cuts before with 0.3mm end mills, and I can do it in plastic because it's soft enough, but doing it in aluminium, bit of a no-go, especially if I'm changing directions. I would have to go so slowly, but of course if you go really slowly, you're also not taking a big enough chip, so you're going to end up rubbing and probably chip welding, so it's a bit of a no-no. However, that's about as small as I'm comfortable to do for real milling, and that's what we're going to be finishing off with today. And it's scary because some of the parts that I'm going to be cutting out are right next to thick walls. Because if we have a look at this part, this is actually quite deep. This is sort of 8.5 millimeters deep or so. Well, if you compare that to the flute length, it means that they're very, very close, and this is going to go right down to the bottom. So I had to make sure that all of my clearances were just about okay, and it gets to within about 0.2 millimeters of the wall here. So I better make sure that everything is exactly as it is in the CAD model, because if I get it wrong, this will probably break and this will have a nasty mar on the finish, and I might have to redo bits. So fingers crossed that doesn't happen. Either way, we're going to pop this on the machine now, hope for the best, and fingers crossed it will come out looking just as good as the base and really fit in, and everything will fit nicely. So wish me luck, let's have a go. Well, how bloody cool is that? I'm absolutely bowled over by the fit and finish and the fact that everything lines up exactly like I was hoping. And I mean, not even kidding, when I was putting the motherboard in my head I was just going like a glove, because it just slid straight in. There were no alignment worries, and it's exactly how I wanted it to be. Same thing for the graphics card, and that was a little bit more nebulous for me because I didn't know at all how that one was going to turn out, because the motherboard obviously has a default I/O panel on it, so you can take measurements and be fairly sure that things are going to work, but completely replacing the PCIe bracket is a little bit more tricky because it's not as clear cut as the motherboard tray. Now, you will have noticed that a mysterious motherboard tray, as I mentioned, has just turned up out of nowhere. Well, I 3D printed that in the background, and this is not the real one. This is just a placeholder so that I could have it mounted. The real one, of course, will be made out of 5mm aluminium and will have a network of combs, including some wooden combs, along the backside for all of the cables. Now, one of the really cool things, and the reason why we've got such a funky shape here, is we're going to be adding some more parts to it. So this part is going to have a wooden accent which runs along the top, and then we're going to have a distro plate over here, and that is going to contain the radiator. That's right, there'll be no fittings for the radiator, well, at least this one. Instead, this one's going to be plumbed directly into a distro plate, which should be quite novel, and I think should fit the whole fit and finish of this build very well. Tubes are going to run from these two ports straight into the back distro, into the radiator, and it's going to come around the back on the other side and go into the graphics card, which is going to be part of its own extra special water block system as well. So there's an awful lot to look forward to. Unfortunately, we are going to take a small break with the project just for a few weeks whilst I work on the 3D model. So up until now, I've been working to a particular 3D model, but it's still largely incomplete. I've been having to make sure that things are very flexible so that I know that all of this is going to work out, but the final details don't have any flexibility in them at all. So things like the woodwork and of course the distro plates. So I need to make sure those are absolutely nailed and final before committing to them, because otherwise it can have pretty drastic consequences, and I don't want to be remaking parts. That would be a disaster. But there's going to be plenty of cool stuff in the meantime, so hoping to have a go at maybe making my proper glass bead setup. So this cardboard box is on its last legs already. It is starting to wear through, so we're going to have to replace that with a proper unit. So that should be good fun. And I'm also hoping to have a try at my first ever live stream. So I thought it'd be quite fun to try live streaming some cam for you. So fingers crossed I can get that all to work. If I can, it should be good fun. Of course, the best way to stay up to date is by subscribing to the channel if you haven't already. You can also find us over on Facebook, Instagram, builds.gg, and of course our Discord server linked below, where I'm always posting little behind the scenes bits and just having a good old chat with everyone. Of course, if you'd like to support the channel, don't forget to pop by our merchandise store linked below as well, and see if anything strikes your fancy. Take care folks, and I'll catch you next time.